Topic 2.5, Natural Disruptions to Ecosystems. We should be able to explain how natural disruptions, both in the short and long term, can impact an ecosystem. Throughout Earth's history, there have been major and minor natural disruptions that have occurred, and we've been able to see that these natural disruptions can be just as great, if not greater, than human-made disruptions that we're aware of. So we can look at different timescales in terms of these processes occurring. If it's a periodic occurrence, that means it's happening at a pretty regular interval. Now, this doesn't mean it's happening often. It could be in the tens of thousands of years interval, but it is regular. Episodic is a more random interval. It doesn't have a very specific pattern to it. And random are just kind of one-off events that don't have any pattern that's observable. So Earth's climate has changed over geologic time for many reasons. Some reasons include the Milankovitch cycles, and this is basically how Earth is positioned in space. So it could be Earth's distance from the sun, or the exact degree of the tilt of Earth's axis, or Earth's wobble, which is how it is rotating on its axis. So all of these have caused some sort of climate change in the past. As we've seen, climate has changed. We've had different glacial periods on Earth. So we've had glacial ice melting and freezing. As this happens, sea level is going to vary significantly, because if we have a glacial period, that means much of what would be ocean water would now be frozen. Wildlife also engages in short-term and long-term migration for many different reasons, but some of these include natural disruptions. So as habitats, or as environmental change occurs, habitats do change with them as well. And this can alter the distribution of species on Earth. So if we look at this graphic on the left, about 18,000 years ago, we were in a glacial period, and 12,000 years ago, that ice sheet started to melt. So the glaciers started to retreat farther north until present day, when you can't even see them on this map. They're all the way up at the Arctic Circle. So as the glaciers were retreating, the climate overall was starting to warm farther and farther north. And as the climate was warming, the tree species were able to shift farther north as well. So we can look at lake sediments up in these areas and look at the pollen that's there to determine what species were there. And then we can determine what temperature it was in that area due to the tree species that we can observe. As environments change, extinction is a possibility for some species. If species don't have the adaptations necessary to survive those changes, or if they can't move to a more favorable environment, it's possible that they will go extinct. There have been 5 global mass extinctions throughout Earth's history. And a mass extinction is a large extinction of species in a relatively short period of time. So it's a pretty quick die-off of lots of different species. The average lifespan of a species is about 1 million to 10 million years. And as of now, 99% of the species that have ever existed are extinct. So we have not even seen the majority of species that have lived on planet Earth. Many scientists believe that we're currently in the 6th extinction, which is a human-induced loss of biodiversity. So this means it's an anthropogenic or a human-caused event. Like we said on the last slide, extinction and mass extinctions do occur naturally, and we have what's called the background extinction rate, which we can see as this dotted line here. So that's the number of species that just typically go extinct due to natural causes over time. Why we think we have a 6th extinction happening is because around the 1800s to 1900s, we can see a dramatic increase in extinction of a variety of different species. So because of that and the advancement of human populations at that time, we can correlate that to the extinction of species. So why is this extinction a problem? Well, we're lowering the genetic diversity, so we have fewer genotypes available. When you have low genetic diversity, those populations are prone to inbreeding, which means that you have very closely related organisms breeding. This can lead to offsprings who either don't have a high chance of survival to begin with, or they have later issues with reproduction and reproduction rates. The higher a genetic diversity is, the more stable an environment is. So if there is some natural disruption, that environment should be able to bounce back to its normal state faster.